All right, so the next problem that I'll go through is number 8. It says solve the right triangle. So that means find the missing side, ED, and then the missing angles as well. Sometimes it kind of doesn't matter what order you do things in. I could find the missing side length first. Since I already have two sides of the right triangle, we could use a Pythagorean theorem. This is kind of not set up the way that I want it to be because C is not the right angle, but it's not triangle ABC either. But what we can set up is 21 squared plus C squared is equal to 75 squared. So then I could subtract 21 squared from each side. C squared equals 75 squared minus 21 squared. I'm going to use my calculator. 75 squared minus 21 squared is 5,184. So that's C squared. And then you could take the square root of that to find the value of C. It says round each answer to the nearest tenth, so I want to make sure I do that. The square root of 5,184 to the nearest tenth is 72. It's exactly 72. So if you remember, these three numbers actually make a Pythagorean triple. And then I could either find angle D first or angle C. It doesn't matter. Let's just say I want to find angle C first. I could use any two out of those three sides to find the measure of angle C. If I use what was given, the 21 and 75, note for angle C, 21 is adjacent, 75 is the hypotenuse. So you have to use the cosine. I could set up the cosine of angle C equals the side adjacent. Again, remember SOHCAHTOA, C-A-H, adjacent over hypotenuse for cosine, over 75. And then you have to remember as well, we're trying to find the measure of an angle, specifically using trig. So the measure of angle C, or I could just write it like this, is the inverse cosine. If you're using trig to find an angle, you have to use an inverse function. So it would look like this, inverse cosine of 21 over 75. And then you use your calculator. It's a second function or a shift function button. The inverse cosine of 21 over 75 or divided by 75. It's about 73.7. So that's angle C. And then lastly, what we could do is find the measure of angle D. Probably the easiest way is just to take the complement of angle C. So 90 minus 73.7 would give us the measure of angle D, and that's 16.3 degrees. You should get the exact same thing if you use an inverse function and you use trig to find the measure of angle D. But it's probably easiest just to take the complement of angle C. Okay, let's run through at least one other problem. We'll go over number 9. Okay, I want to find all the missing sides and all the missing angles. That's what it means to solve the right triangle. I'm going to find the measure of angle N first. You take the complement of 52 degrees. So the complement of 52 degrees, 90 minus 52 is 38 degrees. And then I could find the length of LM or the length of MN. Doesn't matter which one I find first. I'm going to call this lowercase n because it's opposite angle N, that first. This is opposite the 38 degree angle. We're given the hypotenuse, so we could use the sine, just sine, not the inverse sine. We're not trying to find an angle, we're trying to find a side length. So the sine of the acute angle, 38 degrees, is equal to the side opposite, in this case n, over or divided by the hypotenuse. And then to solve this for n, we can multiply each side by 3. Then n equals 3 times the sine of 38 degrees. If you do that on your calculator, you get n to be about, since we're supposed to round to the nearest tenth, 1.8. And then lastly, to find side length mn. Yes, you can use trig, but I'm going to use the Pythagorean theorem. So let that be lowercase l. 1.8 squared plus L squared, this is what we're trying to find, is equal to 3 squared. So I could do L squared equals 9, so that's 3 squared minus 1.8 squared. And then use my calculator, 9 minus 1.8 squared, and then take the square root of that in order to find the length of MN, or what I called L. So the square root of but 5.76. You should get about 2.4. And that's solving right triangle LMNO.